Okay, hello everyone. Today we will be taking up the kangaroo contest 2022. Let's begin. So the first question asking us how many positive three-digit integers are divisible by 13. So we divide 100 and 999 by 13 and we get approximate the value, and we just need to count how many integers are there. So 76 subtract 7 is 69. And question 2, the product of a 10-digit integer is 15. What is the sum of the digit? So 15 must be written as the product of 5, 3, and a bunch of ones, 8 ones, and we just add them together. So 8 times 1 plus 3 plus 5 equals to 16. Question 3. So we just need to notice that when two equally sized squares, they are touching each other, the overlapping arc, they are the same, which means like this arc equal to this arc, and the whole perimeter of this shape is actually the circle itself, which is 2 pi. Question 4. How many real solutions does this have? 0, because this is a square, this is also a square. You want to keep both of them at 0, which means x need to be 2 and negative 2 at the same time, which is impossible. And question 5. So how much fraction of the area of rectangle is shaded? Well, intuitively it's just 1 over 4. And it can be proved very easily, like those two lines, they are symmetrical, right? And since this line segment equals to this line segment, so it is splitting this line segment into 2 equal parts, and this line segment into 2 equal parts. Therefore, this is just a rectangle, and this is also a rectangle, and this is 1/4. So the whole thing is 1/4. Question 6. So 4 lines forming 8 equal angles intersect to form equal 8 angle. Which one of them have the same parameter as the small circle shown? So the small circle have a parameter of 2 pi, and so for the radius to be 2, okay, then the k value must be 1 over 2. And yeah, just solve for the k, and that's how much of the fraction of the whole circle it should cover. So this one has a radius of 4, and it also have a fraction of 4 of the entire this circle. Okay, that means it match, and we cannot find any other arc that satisfy the condition. Question 7. So we need to have those two numbers and make sure that they are having the same sign, and which one of the following conclusion is definitely to be true. So first thing first, if the power is to a even number, we just cross that out because it's going to be positive anyway. It's not going to determine by this, and that's what we have left. So we cross the b out at the same time, because if b is positive, then both of them will be positive. If this is negative, then both of them will be negative. So we just cross them out together, and then we are left with this, and it is obvious that a must be a negative number to have the same sign as a negative number. And question 8, so square lies in the coordinate system as shown, and which of the resulting figure will be looking like. So suppose we are transforming one side of the original square like this, x1 and y in range of 1 to 2, and it's going to be transformed into 1, and y is going to be in range of 1 and 1/2, okay? And it is actually transforming into another smaller side. It's transforming into a side of the smaller square. Okay, and actually it works for all of the sides, so the resulting will be a square, which is this one. Hey, question 9. We are having a bit of trouble here. Question 9. So there are 4 different points. We need to determine the distance between those two midpoints. Alright, so AC is equals to AB plus BC. This is a bunch of relationship, and this is what we want to determine. And this is actually equals to a path of the sum of AC and BD, which is equal to 15, and we pick A. Question 10. Determine how many number of isosceles triangle with integer side length and the longest side, of which there can be more than one of length 11. So, case 1 is there's 2 or 3 sides are length of 11. So, the third side, which is the smaller side, must be greater or equals to 1 less than equals to 11. The number of ways is 11. And case 2 is there's only one side that's equal to 11, which means that the other 2 sides must be the isosceles sides, and 2s1 must be equals to greater than 11 but less than 22, because they cannot go over 11. So we know that s1 must be inside this range. There's only 5 integers that satisfy this. So the total number of ways is 5 plus 11 equals to 16. Question 11. So we are cutting a cuboid of surface area as is cut by 6 planes as shown. Each plane is parallel to a face, but its distance from the face is random. The cuboid is thus separated into 27 smaller parts. What in terms of S is the total surface area of all 27 smaller parts? So when we are making a cut, we are actually creating two different faces. Just imagine like my hand. Like initially we had this top face and like the bottom face, but when you expand it, there's a 1, 2, 3, 4. There's 4 different faces. So each cut, it creates 2 extra faces. So the original S plus 2 extra any extra faces. Okay. So actually, so it's going to be 3 times, because originally we have 2 faces. Each time you create another 2 faces with another cut, right? So we have 2 cut like each time. So so we're gonna have double the surface area, and we're gonna have 3s. Question 12. So Tony looks at the water meter. He noticed that all the digits on the meter are different. How much water will be used until the next time all the digits on the meter are different? So we're gonna try out each value, and we're gonna try to find a result to have not repeating digit, and this is the digit we obtained after this is being added. 92013. They're all different. And question 13. So the largest proper divisor of a number is 2022. And we need to determine the second largest divisor of this number. So this is going to be the original number. We know that to some extent this number has a factor of 2. And it probably just stripped another factor of 2, because to get a proper divisor of a number, you always strip off the smallest divisor. So in this case, we know that it must be 2. So the second smallest divisor must be this number divided by 3, because last time we divided by 2, divided by 3 must be the second most optimal. Question 14. So we have this oddly shape inside a big square, So we know that this side and this side, they are both 1/2 of the side length of the big square, which we make it equals to x. And this is the formula for calculating this shape. Just imagine that when you are trying to completing this shape over here, you're gonna eventually get a like a big rectangle, and each part is going to be 1/2 of the rectangle area. And yeah, this big rectangle is going to have the area of 1/2 of x multiplied by 1/2 x, okay, and we divide it by 2, we get the size of this shape. And yeah, we just obtained using this to obtain the larger the area of the larger square by determining what is the value of x, and subtract that from this small, we subtract this small shape here. And question 15, so we are trying to optimize the map shows a region with 16 cities connected by roads. The government wants to build electricity power plant in some of the cities. Each power plant can provide enough electricity for the city where it is located and any city that's connected to that city by a single road. What is the smallest number of power plants that needed to be built? So this is the optimal way to set up the power plant. For example, this one supplies those 3 and itself, and this one supports this. This one supports this, and this. This one supports this, and this. We optimize it, and it can be proved that we cannot have three power plants because there's total of 11 points, and we know that for a power plant, it can only supply a maximum of 5 cities, right? 5 cities, and yeah, 3 is clearly not enough. Even if we achieve the maximum, 3 times 5 equals to 15, which is less than 16. So we know that B is going to be our answer. And question 16. So 5 number have a mean of this. The mean of the smallest 3 number 19. The mean of the 3 largest 28. What is the median? So this is the equation. Suppose n1 is the smallest, n5 is the largest, and this is, we have the mean, and we just multiply that by the number of element, and this, and we plus those two together and subtract this, and we get 21. Which is the answer. And question E. Okay, my graph is kind of bad, but here's the question. We got this shape over here, and we want to determine the area. So when you are trying to fitting those of the semicircle into those blank, you will get a hexagon. And we just need to calculate the area for the hexagon, and we get the answer. And question 18, so M is playing in a 8-player tournament, and it's like a, yeah, and she knows that she is very good except A, which will beat everyone. And in the first round, the player are into 4 pairs, and the second round 2 pairs, and the third round like the finale. So for the first one, there will be 7 opponents for us to choose from randomly. 7 out of 6 we will be able to promote. And if we manage to get to the second round, and we know that A must be there because he is invincible and he will beat everybody's shit up. So yeah, so we have 3 random opponents, and there's 2 that we can possibly pick in order to move to the finale, okay? and this is the probability that we will be making into the finals, and we subtract that from 1 and obtain the probability in which we will not make to the final. Either we are eliminated in the first or second round. Question 19. So let's take a look at this triangle here and this triangle, and we know that they are similar because they are just parallel, and the hypotenuse of the smaller one is 3 and the bigger one is 5. So the ratio of this height to this big height is 3 to 5, and we know that this height h2 here, h2 is actually the difference of this and this, which is equals to 1. And we can solve for h1 here. That's going to be h1, and we plus 2 here, and we gonna get the answer. That's how we obtain the answer. And question 20. Okay, this one is quite interesting. So this is the layout for the smaller one, and we know that the medium-sized rectangle is next to 9 smaller blocks, and which makes the length of this equals to 9 times the x. And using the ratio here, we can conclude that this side is going to 9x multiplied by x equals to 9x squared. And that's how we get the size of this. And by using those two smaller and medium sized rectangle, and we can gonna form the larger rectangle, and this is going to be how it looks like. And we also know that the smaller size or side of this rectangle and this larger side of rectangle, they also satisfy this ratio here. Therefore, we can solve for x, and yeah, we can just calculate the perimeter, and equals to 30. Question 21. So this one is quite interesting. So suppose digit 1 is our 100th digit, and D2 is going to be our 10th digit, and D3 is going to be our unit digit. So those three numbers multiply together, multiply that by 5 equals to 100. So one key observation is that D3 must be equal to a multiple of 5, since D3 cannot be 0, otherwise the product is going to be 0, which makes D1, D2, D3 all equals to 0, which is not a positive number. And yeah, we know that D3 equals to 5 immediately, and we get this. And we also need to make this same equals to a multiple of 5, so D2 equals to 2 or 7. And we try out those cases and sub in the value. We get this one is invalid, we get a fraction, and this one we get 1. And we get 175 to be the only integer that satisfies this condition. And question 22. So a key observation we must make is going to be, due to the symmetric property of the circle, this small. Okay, let me show you in this graph. So this, if you draw a line down here, this point and edge, and if you draw a line down from C, and you get a point here, this point and this, and due to the symmetric property, this equals to this. Similarly, you draw a line down here and down here, and this one equals to this one, and you can get this part equals to 22 subtract x, and this one equals to 22 subtract x, and this part equals to 12 subtract 8, 4. and using this line we know this line segment, this line segment, and this line segment, and we equate this with this line segment here, and that's the equation we are getting, and we know the value of the x equals to 16. And question 23. So here, this one I don't really appreciate, but there's a maximum of how much of this it could be. So in order to maximize this, we put a large number, the sum of those three, we put a very large number to those two, and a very small number in here, and we determine that the maximum is actually 73. And that's exactly of those, so this must be 1, which is none of those options above. And 24. So a key observation is that this is quite limited, because if you have a higher degree of the polynomial that's greater than 4, it's going to be too big, and we just separate them and we look at the cube and x, and we have this. Since x must have the coefficient must have a upper bound, and this limited how big C1 could be, and we can solving C1, C3, and similarly C0 and C2, and we use that and subbing the value of 10 solve the value here. And the vertices of 20 are numbered in from 1 to 20 in such a way that the number of adjacent vertices is different by either 1 or 2. The side of the 20 whose ends differ by only 1 and colored by red. How many red sides are there? So this is how it looks like. You just jump 2 plus 2 plus 2 until here. When you reach 19, you plus 1 and you minus 2 and going backwards, and you will notice that there's only 1 plus 1 here, and there's only minus 1 here. So there should be only 2 red sides, and I think it can be proved that this is the only valid way to construct the required 20 okay? And question 20, so this thing here is clearly greater than n and less than n plus 1. And this thing here is clearly greater than 3n, less than 3n plus 1. 3n minus n, we get 2n. And the answer is C. And question 27. So notice that this is n greater or equals to 1, not equals to 2. And we immediately get a relationship between A1 and A2. Here, and we reorganize it, we can get a expression of A2 using A1, and we get an expression of, we plug in n equals to 3 equals to this equation, and we get this expression, and we plug in n equals to 1 into this expression, and we get an expression of A3, and we plug this thing into here, as you can see, and we plug in the expression of A1 into here, and it's just a quadratic equation, and we get 2 different solutions, and we pick the one that makes A1 equals to a fraction that between 0 and 1, therefore A2 equals to 4. And question 29. So notice that this is a 30 degree, this angle here, which makes here this is root 3, and this is going to be 2, and the ratio that is going to be 2 root 3, and the area is going to be equals to the side length multiplied by height. Since those two satisfy this ratio here, and the height also satisfies this ratio. It's going to be the square, so 4 over 3, and we get how much fraction is like those parts that's outside of the smaller thing. How much fraction is that of the overall big hexagon? And we know that a pyramid is a third of the 3D crossing volume. And we just multiply this by 1 over 3 and we get 1 over 12. Question 29. So you just kind of reorganize it into this form, and where you can like using some divisor series, and you get those 3 different combinations, and you just plug in this and you get 2 sets of values, and you pick the smaller one, which is 660 to be our minimum. And question 30 is just very easy. You just transform this in terms of minute to our convenience, and you just try every single one of each value and see if the mean have exactly 3 values inside that's going to be below. So you try 1125, you get 647.4, which is have exactly those 3 to below the mean, and others just doesn't work. And that concludes the session for today. Thank you for watching. Bye.